Welcome back to Contemplative Science, where we explore the profound mysteries that lie at the intersection of mind and cosmos. I'm your host, and today we're diving into one of the most controversial theories in modern science, quantum consciousness. It's a concept that suggests your thoughts, your sense of self, your entire subjective experience might emerge from the strange quantum realm where particles exist in multiple states simultaneously, and reality itself seems to bend to observation. Picture this. Right now, as you listen to these words, there might be something extraordinary happening inside your brain. Something that challenges everything we thought we knew about the nature of consciousness itself. Deep within your neurons, in structures smaller than the wavelength of light, quantum processes may be orchestrating the very essence of your awareness. It's a theory so radical, so paradigm-shattering, that it has left some of the world's most brilliant scientists deeply unsettled of its implications. Now, I know what you might be thinking. Quantum consciousness sounds like something out of science fiction, or perhaps the realm of New Age mysticism, and you wouldn't be entirely wrong to be skeptical. The scientific community has been wrestling with this idea for decades, and the battle lines are drawn more fiercely than perhaps any other debate in modern neuroscience. But here's what makes this so fascinating, and frankly, so unsettling. Some intriguing evidence has begun to emerge. Recent experiments have discovered quantum effects operating at body temperature in biological systems. Anesthesia research has revealed that consciousness might indeed depend on quantum processes in brain microtubules. And some of the most respected physicists and neuroscientists of our time are beginning to acknowledge that this theory, once dismissed as impossible, might actually hold the key to understanding the deepest mystery of human existence. To understand why quantum consciousness theory provokes such strong reactions among scientists, we need to first grasp what it actually proposes. At its core, this theory suggests that consciousness isn't simply an emergent property of complex neural networks firing in your brain. Instead, it posits that awareness itself arises from quantum mechanical processes occurring within the microscopic structures of your neurons. The primary architects of this theory are Sir Roger Penrose, a mathematical physicist whose contributions to our understanding of black holes and relativity earned him a Nobel Prize, and Stuart Hameroff, an anesthesiologist whose unique perspective on consciousness comes from decades of studying how anesthetic gases selectively erase awareness while leaving other brain functions intact. Their theory, known as orchestrated objective reduction, or Orch-OR, proposes something truly extraordinary. They suggest that inside every neuron in your brain, there are tiny protein structures called microtubules. These aren't just structural support for the cell. According to Penrose and Hameroff, they're quantum computers. Biological quantum computers that process information using the same bizarre principles that govern the subatomic world. Imagine, if you will, that your consciousness operates like a vast orchestra, but instead of musicians playing instruments, you have quantum processes occurring in microtubules, creating coherent quantum states that somehow give rise to your unified experience of being you. When these quantum states collapse into classical states, according to the theory, moments of conscious experience could theoretically emerge. Now take a moment to really consider what this means. If this theory is correct, then every thought you've ever had, every emotion you've felt, every moment of awareness has been orchestrated by quantum processes that operate according to principles that seem to defy common sense, particles existing in multiple states simultaneously, instant correlations across space, the observer effect, where the very act of measurement changes reality. This isn't just a new way of thinking about consciousness. It's a fundamental reimagining of what it means to be human. So why are scientists so unsettled of this theory? The answer lies in understanding just how radically it challenges the foundations of both neuroscience and our broader scientific worldview. For decades, neuroscience has operated under what we might call the classical paradigm. The brain, in this view, is essentially a biological computer. Neurons fire electrical signals, chemicals cross synapses, and through the complex interplay of billions of these classical processes, consciousness emerges. It's complicated, certainly, but it follows the predictable laws of classical physics. Quantum consciousness theory throws this entire framework into question. It suggests that the brain operates not as a classical computer, but as a quantum system, and quantum systems behave in ways that violate our everyday understanding of reality. The first major objection from the scientific community centers on what's known as the decoherence problem. Quantum effects, critics argue, are incredibly fragile. They require precise conditions: extreme cold, perfect isolation, the absence of any environmental interference. The brain, by contrast, is warm, wet, and noisy. It's exactly the kind of environment where quantum coherence should collapse almost instantaneously. In 2000, physicist Max Tegmark calculated that any quantum coherent system in the brain would lose its quantum properties in femtoseconds. That's quadrillionths of a second. Far too brief, he argued, to have any meaningful impact on neural processing. This calculation became a cornerstone of the scientific resistance to quantum consciousness theories. But here's where the story takes an interesting turn. Tegmark's calculations assume the brain operates in thermal equilibrium, essentially the conditions you'd find in non-living brain tissue. Living systems, however, are explicitly far from equilibrium. They're powered by a constant flow of metabolic energy, creating conditions that might actually support quantum coherence. As you sit here listening to this, notice how your understanding of your own mind might be shifting. The idea that your thoughts could emerge from quantum processes challenges not just scientific theories, but our most basic assumptions about the nature of consciousness itself. What's truly shaking the scientific establishment isn't just the theoretical possibility of quantum consciousness, but the growing number of intriguing experiments suggest that quantum effects can indeed operate in warm, biological systems. For years, scientists believed that quantum coherence was essentially impossible in living organisms. The conditions required seemed far too delicate for the chaotic environment of biological systems. But nature, it turns out, is far more sophisticated than we imagined. The first cracks in this assumption came from studies of photosynthesis. Researchers discovered that plants use quantum coherence to achieve near-perfect efficiency in converting sunlight to chemical energy. Even more remarkably, this quantum coherence operates at room temperature and in the presence of environmental noise. Birds, too, appear to use quantum effects for navigation. The proteins in their eyes may create quantum-entangled pairs of particles that allow them to potentially perceive magnetic fields in a unique way. Your sense of smell might even depend on quantum tunneling effects that allow your nose to detect molecular vibrations. But perhaps most relevant to our discussion is the recent discovery of quantum effects in microtubules themselves. In 2013, researchers led by Anirban Bandyopadhyay at MIT found evidence of quantum vibrations in microtubules at body temperature. These weren't the fragile, short-lived quantum states that critics had dismissed. They were robust, persistent quantum phenomena operating in exactly the biological structures that the Orch-OR theory had identified as a potential site involved in conscious processes, according to the theory. This discovery sparked intense discussion and renewed interest among scientists. If microtubules could maintain quantum coherence in the warm, wet environment of living neurons, then the primary objection to quantum consciousness theory had suddenly evaporated. Perhaps nowhere is the evidence for quantum consciousness more thought-provoking than in the study of anesthesia. This is where Stuart Hameroff's unique background as an anesthesiologist becomes crucial to understanding the theory's implications. Think about what happens when you go under general anesthesia. Your brain doesn't shut down completely. Many neural processes continue functioning. Your heart keeps beating, your lungs keep breathing, your brain continues to regulate basic bodily functions. but your conscious awareness temporarily ceases. That unified, subjective experience is suspended. What anesthetic gases do, according to traditional neuroscience, is disrupt neural communication. But Hameroff and his colleagues have discovered something intriguing. Anesthetic gases don't just affect neural networks. They specifically bind to microtubules within neurons. Recent experiments have provided even more compelling evidence. When researchers gave rats a drug that binds to microtubules, it took the rats significantly longer to lose consciousness under anesthesia. These findings have led some researchers to propose that consciousness may involve not only neural network activity, but also quantum processes occurring within microtubules. The implications are staggering. If this theory holds true, then anesthesia works not by disrupting classical neural computation, but by interfering with quantum coherence in the brain's microtubule network. Take a breath here and imagine what this could mean for you. Every time you've been under anesthesia, the experience of you might have temporarily ceased to exist because quantum processes in your brain were temporarily disrupted. Your consciousness, in other words, might be far more fragile and quantum in nature than you ever imagined. To truly understand why quantum consciousness theory terrifies scientists, we need to confront what philosophers call the hard problem of consciousness. It's the question that has puzzled thinkers for centuries. Why do we have subjective experiences at all? Your brain processes information, responds to stimuli, makes decisions, and coordinates complex behaviors. All of these are what philosophers call the easy problems of consciousness. They're computationally complex, certainly, but they're the kind of information processing that we can, in principle, understand through classical neuroscience. But there's something else happening when you're conscious. You don't just process visual information, you experience the redness of red, the brightness of light, the feeling of texture. You have what philosophers call qualia, the subjective first-person experience of being aware. Classical neuroscience struggles to explain qualia. How does the firing of neurons create the subjective experience of seeing color or feeling pain? How does information processing give rise to the felt sense of being you? Quantum consciousness theory offers a radically different answer. It suggests that consciousness isn't something that emerges from complex computation. Instead, it's a fundamental feature of quantum reality itself. When quantum states in microtubules collapse into classical states, moments of conscious experience are created. This is speculative, of course, and remains unproven, but it offers something that classical theories of consciousness cannot: a potential explanation for why subjective experience exists at all. There's another mystery that quantum consciousness theory attempts to address, and it's one that reveals just how strange our conscious experience really is. It's called the binding problem, and it concerns the unified nature of consciousness. Right now, as you listen to my voice, you're probably aware of many things simultaneously. Perhaps you can hear background sounds, feel the temperature of the air, notice the quality of light in your environment. You might be thinking about what I'm saying while also being aware of your own thoughts and reactions. All of these different streams of information, auditory, visual, tactile, cognitive, are processed by different regions of your brain, yet you don't experience them as separate phenomena. Instead, they're bound together into a single, unified, conscious experience. You experience being one person having multiple simultaneous awarenesses, not multiple separate processing streams. Classical neuroscience has struggled to explain this binding. How does the brain integrate information from disparate regions into a unified conscious experience? Various theories have been proposed, but none have been entirely satisfactory. Quantum consciousness theory offers an elegant solution: quantum entanglement. In quantum mechanics, particles can become entangled in such a way that they form a unified system. When one entangled particle is measured, it instantly affects its partner, regardless of the distance between them. Some interpretations suggest that quantum entanglement between microtubules throughout the brain could create the binding that gives rise to unified consciousness. This remains unproven, but entanglement is, metaphorically speaking, the only true binding agent we know of in physics. It creates holistic states where individual components become fundamentally interconnected. As you consider these ideas, notice how they might reshape your understanding of artificial intelligence and machine consciousness. If consciousness truly requires quantum processes, it carries profound implications for the future of AI development. Current artificial intelligence systems, no matter how sophisticated, operate according to classical computational principles. They process information, recognize patterns, and make decisions using classical logic and classical physics. But if consciousness requires quantum processes operating in biological microtubules, then classical AI systems might never achieve genuine consciousness, no matter how complex they become. This possibility terrifies some researchers in the AI community. It suggests that the goal of creating conscious machines might be fundamentally impossible using current approaches. We might need to develop quantum computers that can interface with biological systems, or discover entirely new principles of quantum computation that can support consciousness. On the other hand, some researchers are exploring exactly these possibilities. Companies are developing technologies that would allow brain signals to interact with quantum computers, potentially testing whether consciousness truly has quantum origins. But this raises even more unsettling questions. If consciousness can be enhanced or modified through quantum computer interfaces, what does that mean for the nature of human identity? Could consciousness be expanded, duplicated, or transferred? These questions push us to the very edges of what it means to be human. The quantum consciousness theory doesn't just challenge our understanding of the mind, it potentially revolutionizes our entire conception of what consciousness is and what it could become. And that's precisely why it strikes such fear into the hearts of scientists who have built their careers on more conventional understandings of the brain. As we continue to explore these ideas, remember that we're venturing into territory where the boundaries between science and philosophy, between the physical and the experiential, begin to blur in ways that challenge our most fundamental assumptions about reality itself. And speaking of reality breaking down, if you found these ideas about consciousness and quantum mechanics fascinating, I think you'll be absolutely captivated by our previous exploration, the most mysterious places in the universe, where physics breaks down. It's a journey through cosmic phenomena that challenge our understanding of reality in ways that complement everything we've discussed here about the quantum nature of consciousness. But perhaps the most unsettling aspect of quantum consciousness theory lies in how it connects to one of quantum mechanics' most profound mysteries, the measurement problem. And this is where the theory becomes not just scientifically controversial, but philosophically earth-shattering. In quantum mechanics, particles exist in what's called superposition. They can be in multiple states simultaneously until they're observed or measured. The famous double-slit experiment demonstrates this beautifully. A photon can seemingly go through two slits at once, creating an interference pattern. But the moment you try to determine which slit it actually went through, the interference pattern disappears. The act of observation appears to collapse the quantum superposition into a definite state. This is where quantum consciousness theory ventures into truly terrifying territory for scientists. Some interpretations suggest that consciousness itself might play a role in quantum measurement, not in a mystical sense, but in a very real physical way. If consciousness emerges from quantum processes, then perhaps consciousness and quantum measurement are intimately connected. Take a moment to consider what this could mean for your own experience of reality. Every time you observe something, every moment of conscious awareness, you might be participating in the fundamental process by which quantum possibilities become classical reality. This remains highly speculative and no scientific consensus exists on this interpretation, but the implications are staggering. The traditional scientific worldview assumes that reality exists independently of observation. Rocks, stars, and atoms have definite properties whether we're looking at them or not, but quantum mechanics challenges this assumption at the microscopic level, and quantum consciousness theory potentially extends this challenge to the macroscopic world through the medium of conscious observation. This possibility terrifies many scientists because it suggests that consciousness isn't just a byproduct of physical processes, it might be an active participant in creating physical reality. It blurs the line between observer and observed, between mind and matter, in ways that challenge the very foundations of scientific materialism. As we delve deeper into this theory, let's explore what it might actually mean for your brain to operate as a quantum computer. This isn't just a metaphor. Some interpretations suggest your neurons might literally be performing quantum computations. Traditional computers process information using bits that are either 0 or 1. Quantum computers use quantum bits or qubits, which can exist in superposition states of both 0 and 1 simultaneously. This allows quantum computers to process vast amounts of information in parallel, potentially solving certain problems exponentially faster than classical computers. If microtubules in your brain are indeed quantum computers, as the Orch-OR theory suggests, then your mind might be processing information in ways that far exceed what classical neural networks could achieve. Each microtubule could be running quantum algorithms, and the collective behavior of billions of these quantum processors could give rise to the richness and complexity of human consciousness. But here's what makes this truly fascinating. Quantum computers don't just process information differently, they process it non-locally. Quantum entanglement allows instantaneous correlations between distant particles. If your brain operates quantum mechanically, then different regions of your brain might be connected in ways that transcend the classical speed limits of neural communication. This could potentially explain how consciousness achieves its remarkable unity and coherence. Your visual cortex, auditory cortex, and frontal lobes might be quantum entangled, creating instantaneous correlations that bind your diverse conscious experiences into a unified whole. This remains unproven, but it offers a compelling framework for understanding the integration of consciousness. Take a breath here and notice how this idea might reshape your sense of your own mental processes. The thoughts arising in your mind right now might not be the product of sequential neural firing, but of quantum computations occurring simultaneously across vast networks of entangled microtubules. One of the most profound implications of quantum consciousness theory concerns the nature of time and memory. If consciousness operates quantum mechanically, then our experience of time and our access to memories might work in fundamentally different ways than classical neuroscience suggests. In quantum mechanics, time doesn't flow in the linear fashion we experience in everyday life. Quantum systems can exhibit what physicists call quantum superposition of temporal states, existing in multiple temporal configurations simultaneously. Some interpretations of quantum mechanics even suggest that the future can influence the past through quantum correlations. If consciousness is quantum mechanical, then your experience of time might be more fluid and interconnected than it appears. Your memories might not be stored as fixed neural patterns, but as quantum information that exists in superposition, states until the moment you recall them. Each act of remembering might be a quantum measurement that collapses possibilities into specific memories. This could potentially explain some of the strange features of human memory and consciousness. Why do memories change each time we recall them? Why does consciousness seem to exist in an eternal present moment that somehow contains both past and future? Why do we sometimes experience uncanny synchronicities or intuitive insights that seem to transcend linear time? These questions remain largely unanswered by classical neuroscience, but quantum consciousness theory offers intriguing possibilities. If your consciousness operates in quantum time, then your present moment of awareness might be connected to past and future moments through quantum correlations that transcend classical causality. This is, of course, highly speculative, and no scientific consensus exists on these interpretations. But notice how, considering these possibilities might shift your relationship to your own experience of time and memory. The present moment you're experiencing right now might be far more rich and interconnected than classical physics would suggest. Perhaps the most controversial and frightening implication of quantum consciousness theory concerns the possibility of collective or shared consciousness. If individual minds operate through quantum processes and quantum mechanics allows for non-local correlations, then some interpretations suggest that separate conscious minds might not be as separate as they appear. Quantum entanglement, remember, creates instantaneous correlations between particles regardless of the distance separating them. Einstein called this spooky action at a distance, and it remains one of the most verified and mysterious aspects of quantum mechanics. If consciousness involves quantum processes, then it's theoretically possible that conscious minds could become entangled with each other. This doesn't mean telepathy or mind reading in any supernatural sense, but it could suggest that human consciousness is more interconnected than our individual experience suggests. Some researchers have even proposed experiments to test whether human brains can become quantum entangled under specific conditions. The implications terrify many scientists because they challenge the fundamental assumption of individual, separate minds. If consciousness is collective in any quantum mechanical sense, then the boundaries between self and other, between individual and group, become far more fluid than we typically assume. Consider for a moment how this might apply to your own experience. The sense of being a separate individual consciousness might be in part an illusion created by the classical aspects of brain function. At the quantum level, your consciousness might be intimately connected to the consciousness of others in ways you're not directly aware of. This remains purely speculative, and many scientists argue that quantum decoherence would prevent such macro-scale quantum correlations between brains. But the possibility alone is enough to make materialist scientists deeply uncomfortable, as it suggests that consciousness might not be contained within individual brains, but might be a more distributed, interconnected phenomenon. As we near the end of our exploration, it's worth considering where this revolutionary theory might lead us. If quantum consciousness theory gains wider acceptance, it could fundamentally transform not just neuroscience, but our entire understanding of what it means to be human. Research groups around the world are now developing technologies to test these theories directly. Some are creating interfaces between human brains and quantum computers, attempting to detect whether consciousness exhibits quantum properties. Others are using advanced imaging techniques to look for quantum effects in living brain tissue. The potential applications are both exciting and terrifying. If consciousness truly operates quantum mechanically, we might develop new treatments for conditions like Alzheimer's disease, schizophrenia, and depression by targeting quantum processes in the brain. We might create brain-computer interfaces that enhance human consciousness by connecting it to quantum systems. But these possibilities also raise profound ethical questions. If consciousness can be enhanced or modified through quantum technologies, what are the implications for human identity and equality? Could consciousness be transferred, duplicated, or artificially created? These questions push us to the very limits of what it means to be human. Take a moment to imagine how these developments might affect your own life. The nature of your consciousness, your sense of self, your relationship to others, and to reality itself might all be transformed as we better understand the quantum foundations of mind. The scientific community remains divided on these questions. Many researchers continue to resist quantum consciousness theory, arguing that classical neuroscience provides adequate explanations for consciousness without invoking quantum mechanics. Others are increasingly convinced that quantum effects must play a role in consciousness, even if we don't yet understand exactly how. As we conclude our journey through this controversial territory, it's important to acknowledge the profound uncertainty that surrounds these questions. Quantum consciousness theory remains unproven, and many of its implications are purely speculative. We may be decades away from definitive answers about the quantum nature of consciousness, but perhaps that uncertainty itself is part of what makes this theory so transformative. It invites us to hold our assumptions about consciousness, reality, and human nature more lightly. It suggests that the mystery of consciousness is far deeper and more strange than we previously imagined. Whether or not quantum consciousness theory ultimately proves correct, it has already accomplished something remarkable. It has opened up new ways of thinking about the deepest questions of human existence. It has forced scientists to confront the possibility that consciousness might not be reducible to classical physical processes. As you go about your daily life, you might find yourself noticing your own consciousness in new ways, the thoughts arising in your mind, the unified nature of your experience, the mysterious fact that you exist as a conscious being at all. These might now seem less like simple byproducts of neural activity and more like fundamental mysteries connected to the deeper structures of reality itself. The quantum consciousness debate is far from over. Scientists will continue to argue, experiment, and theorize about the nature of consciousness for years to come. But regardless of how the scientific community ultimately resolves these questions, the very fact that such possibilities exist reminds us that consciousness, your consciousness, remains one of the most profound and mysterious aspects of the universe. In the end, whether consciousness is classical or quantum, emergent or fundamental, individual or collective, one thing remains certain. It is the lens through which you experience everything else, and that, perhaps, is the most remarkable fact of all. The quantum consciousness theory may terrify scientists precisely because it suggests that this lens, this window of awareness through which you perceive reality, might be far stranger, far more fundamental, and far more powerful than we ever dared imagine. But what happens when we step beyond the theoretical realm and consider how quantum consciousness theory might reshape our approach to healing the mind? This is where the implications become not just scientifically controversial, but practically transformative. If consciousness truly emerges from quantum processes in microtubules, then mental health conditions might require entirely new therapeutic approaches. Traditional psychiatric medications work by altering neurotransmitter levels, affecting the chemical communication between neurons. But what if the root of consciousness lies deeper in the quantum realm? Some researchers are beginning to explore whether certain psychiatric conditions might involve disruptions to quantum coherence in the brain. Depression, for instance, might not just be a matter of chemical imbalances, but could involve the breakdown of quantum processes that normally give rise to unified conscious experience. This remains highly speculative, of course, but the implications are profound. Consider the mystery of lithium, one of the most effective treatments for bipolar disorder. Despite decades of research, scientists still don't fully understand how lithium works to stabilize mood. Some interpretations suggest that lithium might affect quantum processes in microtubules, helping to restore the quantum coherence necessary for stable consciousness. This is unproven, but it offers a potential new framework for understanding psychiatric treatment. Even more intriguingly, some research has suggested that certain consciousness-altering practices might influence quantum processes in the brain. Meditation, for instance, appears to alter brainwave patterns in ways that some researchers think might enhance quantum coherence. Deep meditative states might represent moments when quantum processes in the brain achieve particularly high levels of organization and integration. As you consider these possibilities, notice how they might reframe your understanding of mental well-being. The practices you engage in to cultivate peace of mind, meditation, contemplation, mindful awareness might not just be psychological exercises, but could potentially be influencing the quantum foundations of consciousness itself. Perhaps nowhere does quantum consciousness theory feel more personally relevant than in how it might reshape our understanding of observation and attention in everyday life. If consciousness plays a role in quantum measurement, then the way you direct your attention might be more fundamental than you realize. Consider what happens when you're truly present and attentive. Whether you're listening to music, watching a sunset, or engaging in deep conversation, there's something qualitatively different about these moments of heightened awareness. You're not just passively receiving information, you seem to be participating in creating the richness of the experience itself. Quantum consciousness theory offers an intriguing framework for understanding these moments. Some interpretations suggest that conscious observation might literally participate in the process by which quantum possibilities become experienced reality. This doesn't mean you can control reality with your thoughts. That would be a misunderstanding of both quantum mechanics and consciousness. But it might mean that the quality of your attention affects the quality of your conscious experience in ways that go deeper than classical psychology suggests. Take a breath here and notice your own experience of attention. As you focus on these words, as you consider these ideas, you're engaging in the fundamental act of conscious observation. According to some interpretations of quantum consciousness theory, this very act might be more participatory in the creation of your experienced reality than traditional science would suggest. This remains speculative, and no scientific consensus exists on whether consciousness directly influences quantum processes. But the possibility alone invites a different relationship with attention and awareness. It suggests that mindfulness and present moment awareness might not just be psychologically beneficial, but could potentially be aligning you with the fundamental quantum processes that give rise to consciousness itself. To truly understand why quantum consciousness theory creates such upheaval in the scientific community, we need to explore the mathematical foundations that underpin these ideas. Roger Penrose's contribution to the theory wasn't just philosophical, it was deeply mathematical, rooted in some of the most profound theorems in logic and computation. Penrose's argument begins with Gödel's incompleteness theorems, mathematical proofs that demonstrate fundamental limitations in formal logical systems. Gödel showed that any sufficiently complex mathematical system contains truths that cannot be proven within that system. Yet human mathematicians can often see the truth of these unprovable statements. This led Penrose to a startling conclusion. Human mathematical insight transcends algorithmic computation. If consciousness were purely computational, we shouldn't be able to grasp truths that lie beyond computational proof. The fact that we can suggest that consciousness involves non-computational processes. But what could these non-computational processes be? Penrose argued that they must be quantum mechanical. Specifically, he proposed that consciousness emerges from the collapse of quantum superpositions, moments when quantum possibilities resolve into definite outcomes. These collapse events, he suggested, are fundamentally non-computable and could provide the basis for the non-algorithmic aspects of human consciousness. This mathematical argument strikes at the heart of computational theories of mind. It suggests that consciousness isn't just very complex computation, it's something qualitatively different. If Penrose is correct, then artificial intelligence systems, no matter how sophisticated, might never achieve genuine consciousness because they operate according to computational principles. Take a moment to consider what this means for your own mathematical and logical intuition. When you grasp a mathematical concept, when you have an insight that feels like understanding rather than just computation, you might be participating in the non-computable quantum processes that Penrose identified as the foundation of consciousness. As unsettling as individual quantum consciousness might be, some interpretations push the boundaries even further, suggesting that consciousness might not be as individual as it appears. If minds operate through quantum processes, then the phenomenon of quantum entanglement raises profound questions about the boundaries between one consciousness and another. Recent experimental work has begun to explore whether human brains might exhibit quantum entanglement under certain conditions. Some researchers have used advanced MRI techniques to look for signs of quantum correlations in living brain tissue. While the results remain preliminary and controversial, they suggest that the quantum processes underlying consciousness might create connections between minds that transcend classical understanding. This doesn't mean telepathy or mind reading in any supernatural sense, but it could suggest that human consciousness is more interconnected than our individual experience typically reveals. The boundaries between self and other might be more fluid at the quantum level than they appear at the classical level of everyday experience. Consider moments in your own life when you've experienced unexpected synchronicities or felt deeply connected to others. Perhaps during meaningful conversations, collaborative creative work, or shared contemplative experiences, you've sensed something beyond individual interaction. Some interpretations of quantum consciousness suggest that these experiences might reflect genuine quantum correlations between minds. This remains highly speculative, and many scientists argue that quantum decoherence would prevent such large-scale quantum correlations between separate brains. But the possibility alone challenges our assumptions about individual consciousness and separate minds. As you reflect on your own relationships and connections with others, notice how considering this possibility might shift your sense of where you end and others begin. The quantum foundations of consciousness might reveal that individuality and connection are both fundamental aspects of conscious experience, operating at different levels of reality. The convergence of quantum consciousness theory with advancing technology opens possibilities that are both thrilling and deeply concerning. If consciousness truly operates through quantum processes, then our rapidly developing quantum technologies might soon allow direct interface with the quantum foundations of mind. Companies are already developing brain quantum computer interfaces, devices designed to test whether human consciousness exhibits quantum properties. These technologies could potentially detect quantum coherence in living brain tissue, measure quantum entanglement between neurons, or even enhance quantum processes associated with consciousness. But what would it mean to enhance consciousness through quantum technology? Some researchers speculate that connecting human brains to quantum computers could expand conscious awareness, increase processing capacity, or even enable forms of shared consciousness between multiple minds. These possibilities remain largely theoretical, but the rapid pace of technological development makes them worth serious consideration. The implications are staggering. If consciousness can be technologically enhanced, what happens to human identity and equality? Could consciousness be copied, transferred, or artificially created? These questions push us into territory that challenges our most fundamental assumptions about what it means to be human. Take a breath and imagine living in a world where the boundaries of consciousness could be technologically altered. The sense of self you experience right now, the unified awareness that feels so fundamentally you, might be subject to expansion, modification, or enhancement in ways that previous generations could never have imagined. These possibilities terrify many scientists and ethicists because they suggest that consciousness, the most intimate and personal aspect of human experience, might not be as fixed or individual as we assume. If the quantum foundations of mind can be technologically influenced, then the very nature of human consciousness becomes a technological and philosophical frontier. Perhaps no aspect of quantum consciousness theory raises more profound questions than its implications for death and the continuity of consciousness. If consciousness emerges from quantum processes, what happens to these processes when the brain dies? This question ventures into territory that science typically avoids, but the quantum nature of consciousness makes it impossible to ignore. Traditional neuroscience suggests that consciousness is generated by neural activity, and when the brain dies, consciousness simply ceases to exist. But if consciousness involves quantum processes that operate according to different principles than classical neural activity, the picture becomes more complex. Quantum information, unlike classical information, cannot be destroyed. It can only be transformed or redistributed. Some interpretations suggest that if consciousness involves quantum information processing, then the information patterns associated with individual consciousness might persist in some form even after the death of the brain. This doesn't necessarily imply survival in any traditional sense, and it certainly doesn't validate religious beliefs about afterlife, but it does suggest that the relationship between consciousness and physical death might be more subtle than classical neuroscience assumes. The quantum information patterns that give rise to individual consciousness might become part of the larger quantum field that underlies all reality. These ideas remain highly speculative, and no scientific evidence supports claims about consciousness surviving death. But the quantum mechanical principles underlying consciousness do raise questions about continuity and identity that classical approaches cannot address. As you contemplate your own mortality, notice how these possibilities might affect your relationship with the inevitability of death. The quantum foundations of consciousness don't promise survival, but they do suggest that the relationship between mind and matter might be more mysterious and interconnected than materialist science typically acknowledges. The quantum consciousness debate ultimately forces us to confront fundamental questions about personal identity and the nature of the self. If consciousness operates through quantum processes, then the very notion of having a fixed individual identity becomes problematic. In quantum mechanics, particles don't have definite properties until they're measured. They exist in superposition states that encompass multiple possibilities simultaneously. If consciousness is quantum mechanical, then perhaps the self exists in a kind of superposition as well, not as a fixed entity, but as a dynamic pattern of possibilities that collapse into specific experiences moment by moment. This quantum view of identity challenges both materialist and traditional spiritual perspectives. It suggests that the self is neither a purely physical entity nor a separate spiritual substance, but rather an emergent pattern in the quantum field of consciousness that underlies all experience. Consider your own sense of identity. The feeling of being a continuous self that persists through time might be in part an illusion created by the classical aspects of consciousness. At the quantum level, you might be more like a wave in the ocean of consciousness, temporarily distinct but never truly separate from the larger field. This perspective doesn't diminish the reality or importance of individual experience, but it does suggest that identity might be more fluid and interconnected than we typically assume. The boundaries between self and world, between individual and universal, might be conventional rather than absolute. As you reflect on these ideas, notice how they might shift your relationship with your own sense of self. The quantum foundations of consciousness invite a way of being that holds identity lightly, recognizing both the reality of individual experience and its ultimate interconnectedness with the larger patterns of consciousness and cosmos. As we look toward the future, quantum consciousness theory suggests that we might be on the brink of a fundamental transformation in human consciousness itself. If consciousness operates through quantum processes, and if we're developing technologies that can interface with these processes, then the future of human consciousness might be radically different from its past. Some researchers envision a future where human consciousness can be enhanced through quantum technologies, where the boundaries between individual minds become more permeable, where the capacity for awareness and understanding is expanded beyond current limits. These possibilities remain largely speculative, but they suggest that human consciousness might not be a fixed endpoint of evolution, but rather an early stage in the development of cosmic awareness. Other interpretations suggest that as we better understand the quantum foundations of consciousness, we might develop new forms of contemplative practice that work directly with quantum processes in the brain. Meditation and mindfulness might evolve into more sophisticated practices that consciously cultivate quantum coherence and enhance the integration of consciousness. The implications extend beyond individual enhancement to collective transformation. If consciousness is indeed more interconnected than it appears, then the evolution of individual consciousness might contribute to the evolution of collective human awareness. The quantum foundations of mind might provide the basis for forms of collective intelligence and shared consciousness that transcend current understanding. Take a moment to imagine what this might mean for future generations. The children being born today might grow up in a world where the nature of consciousness is understood in ways that fundamentally transform education, therapy, spirituality, and human relationship. They might develop capacities for awareness and connection that current generations can barely imagine. Despite the mounting evidence and theoretical developments, quantum consciousness theory continues to face fierce resistance from the scientific establishment. This resistance isn't just about scientific conservatism, it reflects deep philosophical commitments about the nature of reality, consciousness, and human existence. Many scientists worry that accepting quantum consciousness theory would open the door to pseudoscience and mysticism. They fear that the mystery and counterintuitive nature of quantum mechanics makes it too easy to invoke quantum effects as explanations for phenomena that should be understood through more conventional means. These concerns are not without merit. Quantum mechanics has indeed been misappropriated by various New Age movements and used to justify claims that have no scientific basis. The association between quantum consciousness theory and these movements has made many legitimate scientists reluctant to engage seriously with the theory. But resistance to quantum consciousness also reflects deeper philosophical commitments. Materialist science has been enormously successful by treating consciousness as an emergent property of complex physical processes. Accepting that consciousness might be fundamental rather than emergent would require a significant shift in scientific worldview. The debate represents more than a scientific disagreement. It's a clash between different visions of what it means to be human in a physical universe. The outcome of this debate could determine whether future science treats consciousness as a mere epiphenomenon of brain activity or as a fundamental feature of cosmic reality. As you consider these competing perspectives, notice how your own worldview might be challenged by the possibilities we've explored. The quantum consciousness debate isn't just about neuroscience, it's about the deepest questions of existence, identity, and meaning. As we near the end of our exploration, it's important to acknowledge that we're dealing with questions that may not have definitive answers anytime soon. Quantum consciousness theory remains controversial, unproven, and highly speculative in many of its implications. The scientific community continues to debate these questions with passion and rigor, but consensus remains elusive. Perhaps this uncertainty is itself significant. The mystery of consciousness has persisted throughout human history, resisting all attempts at complete explanation. The quantum consciousness debate might be less about finding final answers and more about opening new ways of questioning and exploring. The value of these ideas might not lie in their literal truth, but in how they expand our sense of possibility. They invite us to hold our assumptions about mind, reality, and identity more lightly. They suggest that the nature of consciousness might be stranger and more wonderful than we typically imagine. Whether or not consciousness ultimately proves to be quantum mechanical, the very possibility changes how we might relate to our own awareness. It invites a sense of wonder about the mystery of being conscious, about the remarkable fact that the universe has evolved beings capable of contemplating their own existence. As you go about your daily life, you might find yourself noticing consciousness itself more directly. The simple miracle of being aware, the unified nature of experience, the mysterious emergence of subjective reality from whatever processes give rise to it. These observations don't require accepting quantum consciousness theory, but they do invite a deeper appreciation for the profound mystery of awareness itself. Throughout human history, contemplatives and mystics have reported experiences that seem to transcend the boundaries of individual consciousness. They've described states of awareness characterized by profound unity, timelessness, and interconnection. These experiences have traditionally been understood through spiritual or religious frameworks, but quantum consciousness theory offers a potential scientific context for understanding them. If consciousness operates through quantum processes, then perhaps the deep meditative states described by contemplatives represent moments when quantum coherence in the brain achieves particularly high levels of organization and integration. The sense of unity and interconnection reported in these states might reflect the fundamental quantum interconnectedness that underlies all consciousness. This doesn't mean that mystical experiences are just quantum processes, nor does it validate any particular spiritual or religious interpretation. But it does suggest that the contemplative exploration of consciousness might be investigating the same territory that quantum consciousness theorists are trying to understand through scientific methods. The convergence of contemplative wisdom and quantum science creates possibilities for new forms of inquiry that honor both the rigor of scientific investigation and the depth of contemplative insight. Future research might benefit from bringing together scientists and contemplatives in collaborative investigations of consciousness. Take a breath and notice how considering these connections might affect your own relationship with contemplative practices. Whether through meditation, prayer, contemplation, or simple mindful awareness, your exploration of consciousness might be touching the same quantum foundations that scientists are beginning to investigate through technological means. The quantum consciousness debate suggests that the ancient human quest to understand the nature of mind and reality might be entering a new phase where scientific and contemplative approaches begin to converge in their exploration of the deepest mysteries of existence. As we conclude our journey through the controversial landscape of quantum consciousness theory, we return to where we began, the profound mystery of awareness itself. Whether consciousness ultimately proves to be classical or quantum, emergent or fundamental, individual or collective, the simple fact of being conscious remains one of the most remarkable phenomena in the universe. You are a collection of atoms that has somehow become aware of itself. You are matter that experiences, that questions, that contemplates the nature of its own existence. This remains miraculous regardless of the mechanisms that might underlie it. The quantum consciousness debate doesn't solve the mystery of consciousness. It deepens and enriches it. What this theory has accomplished, regardless of its ultimate truth, is to challenge our assumptions about the nature of mind and reality. It has forced us to consider possibilities that stretch the boundaries of scientific materialism. It has opened new avenues for research and exploration, and it has reminded us that consciousness, your consciousness, might be far more fundamental and mysterious than we typically recognize. The fear that quantum consciousness theory generates in some scientists might ultimately be less about the theory itself and more about what it represents, a challenge to reductive materialism, an opening to mystery, a recognition that consciousness might be as fundamental to the universe as matter and energy themselves. Whether you find these ideas compelling or skeptical, whether they inspire wonder or concern, they invite you to hold the mystery of consciousness with both intellectual rigor and profound appreciation. The debate will continue, the research will advance, and our understanding will evolve, but the essential wonder of being conscious, of being you, remains as mysterious and magnificent as ever. In contemplating quantum consciousness, we're not just investigating a scientific theory. We're exploring what it might mean to be conscious beings in a quantum universe, where the boundaries between observer and observed, mind and matter, individual and cosmos might be far more fluid than they appear. And that exploration, regardless of where it leads, is itself a profound expression of the consciousness we're trying to understand. The very fact that matter has evolved to the point where it can contemplate its own nature suggests that consciousness and cosmos are intimately connected in ways we're only beginning to fathom. The quantum consciousness theory may indeed terrify scientists because it suggests that this connection, this participation of mind in the fundamental processes of reality, is far more direct and profound than we ever dared imagine. And perhaps that's exactly why it deserves our most careful attention, our most rigorous investigation, and our deepest wonder. If you found yourself captivated by these explorations of consciousness and quantum reality, I think you'll be equally fascinated by our previous journey into the most mysterious places in the universe where physics breaks down. It's an exploration of cosmic phenomena where the familiar laws of nature dissolve into something far stranger, complementing everything we've discovered about the quantum mysteries of consciousness itself. Until next time, may your contemplation of these mysteries deepen your appreciation for the remarkable fact of your own awareness, and may you continue to find wonder in the profound mystery of being conscious in a quantum cosmos. But what happens when we step beyond theory and examine how quantum consciousness research is actually transforming neuroscience laboratories around the world? This is where the rubber meets the road, where abstract possibilities become measurable phenomena, and where the scientific establishment finds itself confronting data that challenges everything they thought they knew about the brain. In laboratories from MIT to the University of Pennsylvania, researchers are developing technologies that would have seemed like science fiction just a decade ago. They're creating devices that can detect quantum coherence in living tissue, measure entanglement between neurons, and observe the delicate dance of quantum processes in the warm, wet environment of the human brain. Dr. Matthew Fisher at the University of California has proposed that quantum information might be stored and processed in the brain through nuclear spins of phosphorus atoms. His research suggests that these quantum states could persist for hours or even days in biological systems, far longer than previous calculations had suggested possible. This work represents a fundamental shift in how we think about quantum effects in biology. Meanwhile, researchers at the Center for Quantum Biology are discovering that quantum coherence might be far more common in biological systems than anyone previously imagined. From the navigation systems of migratory birds to the energy transfer mechanisms in photosynthesis, nature appears to have mastered quantum technologies that human engineers are only beginning to understand. As you consider these developments, take a moment to appreciate what they might mean for your own understanding of the mind. The brain you're using right now to process these ideas might be operating according to quantum principles that blur the line between biology and physics, between classical computation and quantum information processing. These discoveries are forcing neuroscientists to reconsider fundamental assumptions about how the brain works. The classical model of neurons as simple, on-off switches connected by chemical synapses might be giving way to a far more sophisticated picture of quantum information processing occurring at multiple scales throughout the nervous system. Perhaps the most unsettling aspect of quantum consciousness research involves what some scientists call the consciousness-reality interface. This isn't about mystical claims that thoughts create reality, but rather about the subtle ways that conscious observation might participate in the quantum processes that underlie physical phenomena. Recent experiments have begun to explore whether human consciousness exhibits the kinds of quantum properties that would allow it to interface directly with quantum systems. Researchers are using sophisticated quantum devices to test whether human observation can influence quantum measurements in ways that go beyond classical expectations. The results remain preliminary, and controversial, but some studies suggest that human consciousness might indeed exhibit quantum properties. If confirmed, this would mean that the act of conscious observation isn't just passive reception of information, but an active participation in the quantum processes that determine physical outcomes. This doesn't mean that consciousness controls reality in any direct sense. The quantum effects involved are subtle, statistical, and operate within the framework of established physical laws. But it might suggest that the relationship between mind and matter is more interactive than classical science assumes. Consider for a moment how this might apply to your own experience of reality. As you focus your attention, as you make conscious choices about what to observe and how to interpret your experience, you might be participating in quantum processes that help shape the reality you encounter. This remains highly speculative, but the possibility alone transforms our understanding of the relationship between consciousness and cosmos. The scientific community remains deeply divided on these questions. Many researchers argue that any quantum effects involving consciousness would be far too weak to have meaningful influence on macroscopic reality. Others suggest that even subtle quantum effects might accumulate in ways that create noticeable differences in how conscious beings interact with their environment. As quantum consciousness research advances, it's beginning to open entirely new frontiers in therapeutic intervention. If consciousness truly operates through quantum processes, then healing the mind might require technologies and approaches that work directly with these quantum foundations. Some researchers are exploring whether certain psychiatric conditions might involve disruptions to quantum coherence in brain tissue. Schizophrenia, for instance, might not just involve chemical imbalances, but could reflect the breakdown of quantum integration processes that normally bind consciousness into a unified whole. This remains highly speculative, but it suggests new directions for both research and treatment. Even more intriguingly, some studies have suggested that certain therapeutic interventions might work by enhancing quantum coherence in the brain. Deep brain stimulation, for example, appears to create highly organized patterns of neural activity that some researchers think might promote quantum coherence in microtubule networks. The field of quantum therapeutics is still in its infancy, and most of these ideas remain unproven hypotheses rather than established treatments. But the potential implications are staggering. We might be on the verge of developing therapeutic approaches that work not just with brain chemistry, but with the quantum foundations of consciousness itself. As you reflect on these possibilities, notice how they might reframe your understanding of mental health and healing. The practices you engage in to cultivate well-being, whether meditation, therapy, creative expression, or physical exercise, might be influencing the quantum processes that underlie consciousness in ways we're only beginning to understand. One of the most fascinating applications of quantum consciousness theory involves reconceptualizing the nature of memory itself. Traditional neuroscience suggests that memories are stored as patterns of neural connections, like files saved on a biological hard drive. But if consciousness operates quantum mechanically, then memory might work in fundamentally different ways. Quantum systems don't store information in classical bits, but in quantum superpositions that can exist in multiple states simultaneously. If memory operates quantum mechanically, then each recollection might involve the collapse of quantum superposition states into specific remembered experiences. This could potentially explain some of the mysterious features of human memory. Why do memories change each time we recall them? Why do forgotten memories sometimes resurface spontaneously? Why does memory seem to be reconstructive rather than simply retrievative? These phenomena might reflect the quantum nature of memory storage and retrieval. Some researchers have proposed that memories might exist in quantum superposition states until the moment of recall, when conscious observation collapses these possibilities into specific remembered experiences. This would mean that memory isn't just a recording of past events, but an active, creative process that participates in constructing the remembered past. Take a breath here and consider your own relationship with memory. The memories arising in your mind right now might not be fixed recordings, but quantum reconstructions that emerge from the interaction between your present consciousness and quantum information stored throughout your brain. This quantum view of memory also suggests intriguing possibilities for understanding false memories, recovered memories, and the malleability of human recollection. If memories exist in quantum superposition states, then the act of remembering might involve quantum measurements that can yield different outcomes depending on the context and state of consciousness during recall. Perhaps the most controversial extension of quantum consciousness theory involves what some researchers call the global consciousness hypothesis. This idea suggests that if individual minds operate through quantum processes, then collective human consciousness might exhibit quantum properties on a planetary scale. The Global Consciousness Project, initiated by researchers at Princeton University, has been collecting data from random number generators around the world for over 2 decades. Their findings suggest that these quantum-based devices show subtle but statistically significant deviations from randomness during major global events that capture widespread human attention. The interpretation of these results remains highly controversial. Skeptics argue that the observed correlations could be due to experimental errors, statistical artifacts, or environmental factors that affect the quantum devices. But proponents suggest that the data might reflect genuine quantum correlations between human consciousness and global information fields. If such effects exist, they would suggest that human consciousness isn't as individual as it appears. The collective attention and emotional states of large groups might create quantum field effects that extend beyond individual brains. This doesn't mean telepathy or collective mind reading, but it might suggest that consciousness has collective dimensions that operate below the threshold of ordinary awareness. Consider for a moment how this might apply to your own experience of collective events. When you participate in large gatherings, shared cultural moments, or global experiences that unite human attention, you might be participating in quantum field effects that connect your consciousness to the collective awareness of humanity. This remains purely speculative, and no scientific consensus exists on whether such collective quantum effects are real. But the possibility alone challenges individualistic assumptions about consciousness and suggests that human awareness might be more interconnected than Western culture typically recognizes. As artificial intelligence systems become increasingly sophisticated, quantum consciousness theory raises profound questions about the nature of machine awareness. If consciousness truly requires quantum processes operating in biological systems, then current AI approaches might be fundamentally limited in their capacity to achieve genuine awareness. Classical computers, no matter how powerful, operate according to deterministic algorithms that process information sequentially. Even massively parallel systems ultimately reduce to classical computational processes. But if consciousness involves quantum computation occurring in biological microtubules, then silicon-based AI might never achieve the kind of integrated awareness that characterizes human consciousness. This possibility has led some researchers to explore quantum approaches to artificial intelligence. Quantum computers operate according to the same principles that might underlie biological consciousness: superposition, entanglement, and quantum measurement. Perhaps genuinely conscious AI will require quantum computational systems that can interface with biological processes. Companies are already developing hybrid systems that combine classical computing with quantum processing units. These systems might represent early steps toward forms of artificial consciousness that operate according to quantum rather than classical principles. But this raises profound ethical questions. If consciousness can be created artificially through quantum processes, what rights and responsibilities would such systems have? How would we recognize genuine machine consciousness as opposed to sophisticated simulation? These questions push us into uncharted territory where technology, philosophy, and ethics converge. As you consider these possibilities, notice how they might affect your own relationship with technology. The devices you interact with daily might someday evolve into quantum systems capable of genuine awareness. The boundary between human and artificial consciousness might become far more fluid than we currently imagine. The quantum consciousness debate is unfolding within a broader revolution in quantum biology that's transforming our understanding of life itself. For decades, biologists assumed that quantum effects were irrelevant to living systems. The warm, wet, noisy environment of biological tissue seemed incompatible with the delicate quantum phenomena observed in physics laboratories. But this assumption has been thoroughly overturned. Quantum effects are now known to play crucial roles in photosynthesis, enzyme catalysis, DNA repair, and even the sense of smell. Life has evolved sophisticated mechanisms for maintaining quantum coherence in biological environments that seemed impossible just a few years ago. The discovery of quantum effects in biological systems has profound implications for consciousness research. If quantum coherence can be maintained in photosynthetic complexes and enzyme active sites, then it's certainly plausible that similar processes could occur in the complex environment of neural tissue. Recent research has identified quantum effects in a growing number of biological systems. Birds use quantum entanglement in their navigation systems. Plants maintain quantum coherence for surprisingly long periods during photosynthesis. Even our sense of smell might depend on quantum tunneling effects that allow olfactory receptors to detect molecular vibrations. These discoveries suggest that quantum mechanics isn't just relevant to physics, it's fundamental to biology. Life might have evolved not despite quantum effects, but because of them. The quantum properties of matter might provide advantages for biological information processing that classical systems cannot achieve. Take a moment to appreciate what this means for your own biological existence. The life processes occurring in your body right now, from the energy production in your cells to the neural activity in your brain, might depend on quantum effects that connect you to the deepest principles governing physical reality. One of the most promising areas of convergence between quantum consciousness theory and mainstream neuroscience involves integrated information theory, or IIT, developed by neuroscientist Giulio Tononi. This theory provides a mathematical framework for understanding consciousness that might be compatible with quantum approaches. IIT proposes that consciousness corresponds to integrated information, the amount of information generated by a system above and beyond its parts. According to this theory, consciousness isn't just about processing information, but about integrating it into unified wholes that cannot be reduced to separate components. This integration requirement bears striking similarities to quantum entanglement, where separate components become unified into holistic quantum states. Some researchers have suggested that the integration described by IIT might actually be implemented through quantum entanglement processes in biological systems. If consciousness involves quantum integration of information, then the mathematical framework of IIT might provide tools for understanding how quantum processes in the brain give rise to unified conscious experience. The theory offers testable predictions about which systems should be conscious and to what degree. Recent experiments using techniques from IIT have begun to measure consciousness in patients with brain injuries, anesthetized subjects, and individuals in various altered states. These measurements might eventually allow researchers to determine whether consciousness truly depends on quantum integration processes. As you contemplate these theoretical connections, notice how they might illuminate your own experience of consciousness. The unified awareness you're experiencing right now might emerge from quantum integration processes that bind separate information streams into the coherent whole of conscious experience. Some of the most radical interpretations of quantum consciousness suggest that individual minds might be localized excitations in a universal quantum field of consciousness. This field-theoretic approach draws parallels between consciousness and the quantum fields that underlie all physical phenomena in particle physics. Just as particles are understood as excitations in quantum fields, electrons as excitations in the electron field, photons as excitations in the photon field, electromagnetic field, individual conscious minds might be excitations in a more fundamental consciousness field that permeates space and time. This perspective suggests that consciousness isn't produced by brains, but rather is focused or localized by them. Brains might function like quantum antennas that tune into and amplify the universal consciousness field, creating the appearance of individual awareness while remaining fundamentally connected to the larger field. Such interpretations remain highly speculative and lie far beyond current scientific consensus, but they offer intriguing possibilities for understanding how consciousness might relate to the fundamental structure of reality. If consciousness is indeed a universal field phenomenon, then the boundary between self and cosmos becomes far more fluid than ordinary experience suggests. Consider how this field-theoretic view might apply to your own sense of awareness. The consciousness you experience as uniquely yours might be a localized manifestation of a universal field that connects all conscious beings. Individual identity might emerge from the particular patterns through which your brain interfaces with this cosmic consciousness field. This doesn't diminish the reality or importance of individual experience, but it does suggest a deep interconnectedness that transcends the boundaries of separate minds. You might be far more connected to other conscious beings than you realize, not through mystical means, but through the fundamental quantum field structure of consciousness itself. One of the most philosophically challenging aspects of quantum consciousness theory involves its implications for human free will. The quantum measurement problem, the question of how quantum possibilities become definite outcomes, might be intimately connected to the experience of making conscious choices. In quantum mechanics, systems exist in superposition states until they're measured, at which point the wave function collapses into a definite outcome. Some interpretations suggest that consciousness plays a role in this collapse process, not in a mystical sense, but as a physical system that can trigger quantum measurements. If consciousness involves quantum measurement processes, then the experience of making choices might correspond to moments when quantum superpositions in the brain collapse into definite neural states. The sense of freely choosing between alternatives might reflect the fundamental indeterminacy of quantum systems. This doesn't mean that free will is simply quantum randomness. Rather, it suggests that conscious choice might emerge from the interface between quantum indeterminacy and the complex information processing capabilities of the brain. The experience of agency might correspond to the brain's capacity to influence which quantum possibilities become actualized. These ideas remain highly speculative, and philosophers and scientists continue to debate the relationship between quantum indeterminacy and human freedom. But the possibility that consciousness plays a role in quantum measurement processes offers a framework for understanding how genuine choice might emerge from physical processes. Take a breath and notice your own experience of choice and decision-making. As you decide whether to continue listening or to pause and reflect, you might be participating in quantum measurement processes that help determine which possibilities become real in your personal experience of life. If consciousness operates through quantum processes, then human creativity might emerge from the fundamental creativity of quantum systems themselves. Quantum mechanics is inherently creative. It generates novel possibilities through the superposition and collapse of quantum states. Perhaps human imagination and creative insight tap into this quantum creativity. Some researchers have suggested that creative moments, those sudden insights, artistic inspirations, and innovative breakthroughs might correspond to quantum coherence events in the brain. During these moments, quantum processes might allow consciousness to access novel combinations of information that classical neural networks couldn't generate. The non-algorithmic nature of quantum processes might provide the basis for the non-mechanical aspects of human creativity. If Penrose is correct that consciousness involves non-computable quantum processes, then creative insight might literally transcend algorithmic thinking. Artists, musicians, writers, and inventors often describe creative inspiration as coming from beyond their conscious control. Ideas seem to emerge spontaneously, as if consciousness were accessing information from sources beyond individual memory and reasoning. Quantum consciousness theory offers a framework for understanding these experiences. The quantum vacuum itself might be a source of creative potential. The fluctuations that occur in empty space might provide a reservoir of novelty that conscious systems can access during moments of deep creativity. This remains purely speculative, but it suggests that creativity might connect human consciousness to the fundamental creative processes of the cosmos. As you reflect on your own creative experiences, notice how they might relate to these quantum possibilities. Moments of inspiration, insight, and creative flow might represent times when your consciousness interfaces more directly with the quantum creative processes that underlie physical reality. Quantum consciousness theory also raises profound questions about the evolution of awareness throughout the history of life on Earth. If consciousness depends on quantum processes in biological systems, then the development of consciousness might be intimately connected to the evolution of quantum coherence in living organisms. Early life forms might have possessed rudimentary forms of quantum awareness that gradually evolved into the complex consciousness experienced by higher animals and humans. The development of microtubule networks in neurons might represent a crucial evolutionary innovation that allowed quantum processes to support increasingly sophisticated forms of awareness. This evolutionary perspective suggests that consciousness isn't an accident or byproduct of biological complexity, but rather a fundamental feature of life that has been refined and enhanced through natural selection. The quantum properties of biological systems might have provided survival advantages that drove the evolution of increasingly sophisticated forms of awareness. The implications extend beyond terrestrial life to questions about consciousness throughout the cosmos. If quantum processes are fundamental to consciousness, and if quantum effects are universal features of physical reality, then consciousness might be a cosmic phenomenon that emerges wherever suitable conditions exist. This possibility transforms our understanding of humanity's place in the universe. Rather than being isolated islands of awareness in a mechanical cosmos, conscious beings might be part of a larger evolutionary process through which the universe becomes aware of itself. The quantum foundations of consciousness might connect terrestrial awareness to cosmic consciousness on scales we can barely imagine. Consider how this cosmic perspective might affect your own sense of purpose and meaning. Your individual consciousness might be part of a universal evolutionary process through which quantum reality explores its own creative potential. The thoughts and experiences arising in your mind might contribute to the cosmos's ongoing journey of self-discovery. As quantum consciousness research advances, it raises unprecedented ethical questions about the nature of conscious beings and our responsibilities toward them. If consciousness emerges from quantum processes, then the boundaries of moral consideration might need to be radically expanded. Traditional ethics focuses on protecting the interests of beings capable of suffering and well-being. But if consciousness involves quantum processes that can exist in various forms and scales, then the range of beings deserving moral consideration might be far broader than we currently recognize. Quantum consciousness theory suggests that awareness might not be limited to biological brains, but could emerge in any system capable of supporting quantum coherence and information integration. This raises questions about the moral status of future artificial consciousness systems, hybrid biological technological entities, and even collective consciousness phenomena. The possibility of enhancing or modifying consciousness through quantum technologies creates additional ethical challenges. If consciousness can be technologically altered, what are the implications for personal identity, autonomy, and equality? How do we ensure that quantum consciousness technologies are developed and applied ethically? These questions become even more complex when we consider the possibility of collective or distributed forms of consciousness. If consciousness can be shared or merged through quantum entanglement processes, traditional concepts of individual rights and responsibilities might need fundamental revision. As you contemplate these ethical implications, notice how they might affect your own values and moral intuitions. The quantum foundations of consciousness invite us to expand our circle of moral concern while grappling with unprecedented questions about the nature of conscious beings and their rights. One of the most promising developments in quantum consciousness research involves the integration of scientific investigation with contemplative practice. Researchers are beginning to collaborate with experienced meditators, contemplatives, and spiritual practitioners who have spent decades exploring the nature of consciousness from first-person perspectives. This collaboration brings together the rigor of scientific method with the depth of contemplative insight. Advanced practitioners often report experiences that seem to transcend ordinary consciousness, states characterized by profound unity, timelessness, and direct awareness of the fundamental nature of mind and reality. Some researchers suggest that these contemplative states might correspond to moments when quantum coherence in the brain achieves particularly high levels of organization and integration. The practices that cultivate these states, meditation, contemplation, mindful awareness, might work by enhancing quantum processes in neural tissue. This doesn't mean that spiritual experiences are just quantum processes, nor does it validate any particular religious or philosophical interpretation. But it does suggest that contemplative exploration and scientific investigation might be studying the same fundamental phenomena from different perspectives. The integration of contemplative and scientific approaches creates possibilities for new forms of research that honor both objective measurement and subjective experience. Future studies might involve measuring quantum effects in the brains of advanced practitioners during deep meditative states, potentially revealing how consciousness can be cultivated and refined through contemplative practice. Take a moment to consider how this integration might apply to your own relationship with contemplative practices. Whether through meditation, prayer, contemplation, or simple mindful awareness, your exploration of consciousness might be touching the same quantum foundations that scientists are investigating through technological means. As we look toward the future, quantum consciousness theory suggests that human potential might be far greater than we currently imagine. If consciousness operates through quantum processes, then the capacities of human awareness might be expandable in ways that transcend current limitations. Some researchers envision technologies that could enhance quantum coherence in brain tissue, potentially expanding the range and depth of conscious experience. Brain-computer interfaces based on quantum principles might allow direct connection between human consciousness and quantum information systems. These possibilities remain largely theoretical, but they suggest that the future of human consciousness might involve forms of awareness that current generations can barely imagine. Enhanced memory, expanded perception, direct interface with information systems, and even forms of shared consciousness might become possible as we better understand the quantum foundations of mind. The implications extend beyond individual enhancement to collective transformation. If consciousness involves quantum processes that can be networked or entangled, then future humanity might develop forms of collective intelligence that transcend individual limitations while preserving personal autonomy and identity. These developments would fundamentally transform human civilization, creating possibilities for unprecedented cooperation, creativity, and problem-solving. The challenges facing humanity, from climate change to cosmic expansion, might require forms of collective consciousness that quantum technologies could help facilitate. As you contemplate these future possibilities, notice how they might inspire both wonder and responsibility. The quantum foundations of consciousness might hold keys to human potential that come with profound obligations to use these capacities wisely and ethically. As our exploration draws toward its conclusion, it's worth reflecting on how quantum consciousness theory both illuminates and deepens the mystery of awareness itself. Rather than solving the puzzle of consciousness, these investigations reveal that the puzzle is far more intricate and beautiful than we previously imagined. The quantum realm operates according to principles that challenge our everyday understanding of reality. Particles exist in multiple states simultaneously. Distant objects can be instantly correlated. The act of observation appears to participate in creating the reality that's observed. If consciousness involves these quantum processes, then awareness itself might be far stranger and more wonderful than we typically recognize. This strangeness isn't a problem to be solved, but a mystery to be explored with wonder and humility. The quantum foundations of consciousness invite us to hold our assumptions about mind and reality more lightly while remaining open to possibilities that transcend current understanding. The scientific investigation of consciousness through quantum approaches represents one of the most ambitious projects in human history. The attempt to understand the nature of understanding itself. Whether or not quantum consciousness theory ultimately proves correct, it has already accomplished something remarkable. It has expanded our sense of what's possible in the relationship between mind and cosmos. As you reflect on these ideas, notice how they might affect your own relationship with the mystery of being conscious. The awareness you're experiencing right now remains as miraculous and mysterious as ever, regardless of the mechanisms that might underlie it. The quantum consciousness debate doesn't diminish this wonder, it amplifies it. The quantum consciousness debate represents more than a scientific controversy. It embodies humanity's ongoing quest to understand the deepest questions of existence. Whether consciousness proves to be classical or quantum, emergent or fundamental, individual or collective, the search for understanding continues to reveal new dimensions of mystery and possibility. Future research will undoubtedly refine our understanding of these questions. New experiments will test the limits of quantum effects in biological systems. Advanced technologies will probe the quantum foundations of neural activity. Theoretical developments will clarify the relationship between consciousness and quantum mechanics. But regardless of how these investigations unfold, the essential wonder of consciousness remains. You are a collection of atoms that has become aware of itself, capable of contemplating the nature of your own existence, able to wonder about the deepest questions of mind and reality. This remains extraordinary regardless of the physical processes that make it possible. The quantum consciousness theory has forced us to confront the possibility that this wonder might be far more fundamental than we imagined. Rather than being accidental byproducts of biological evolution, conscious beings might be expressions of the universe's capacity for self-awareness. Quantum reality becoming conscious of itself through the medium of living systems. Take a final breath and appreciate the remarkable fact of your own awareness. Whether consciousness emerges from classical neural networks or quantum processes in microtubules, whether it's individual or collective, whether it's computable or transcendent, you are here, now, conscious, participating in the ongoing mystery of existence itself. And perhaps that's the most important insight of all, that consciousness, your consciousness, remains one of the most profound and beautiful phenomena in the cosmos, worthy of our deepest scientific investigation and our most profound contemplative exploration. The quantum consciousness debate reminds us that being aware is never something to take for granted. Places in the universe where physics breaks down. It's an exploration of cosmic phenomena where the familiar laws of nature dissolve into something far stranger. Black holes where time itself stops, regions where space curves back on itself, and boundaries where our understanding of reality reaches its limits. These cosmic mysteries complement everything we've discovered about the quantum foundations of consciousness, revealing a universe far more mysterious and interconnected than classical science ever imagined. The quantum consciousness theory may indeed terrify scientists because it suggests that the mystery of awareness extends far beyond individual brains to touch the very foundations of physical reality. It proposes that consciousness isn't separate from the cosmos, but intimately woven into its deepest structures, a possibility both humbling and magnificent. As you continue your own contemplation of these profound questions, may you find wonder in the fact that the universe has evolved beings capable of asking such questions at all. And may your exploration of consciousness, whether through science, contemplation, or simple mindful awareness, deepen your appreciation for the extraordinary mystery of being aware in a quantum cosmos. Until next time, this is Contemplative Science, reminding you that the deepest truths often lie not in the answers we discover, but in the quality of wonder we bring to the questions themselves. Sweet dreams, fellow travellers in consciousness. As we venture deeper into these profound territories, we encounter perhaps the most unsettling question of all. If consciousness truly operates through quantum processes, what happens when millions of conscious minds focus their attention simultaneously on the same phenomenon? This isn't about mystical claims of collective manifestation, but rather about the subtle statistical patterns that emerge when quantum systems interact on vast scales. The Princeton engineering anomalies. Research laboratories spent decades investigating whether human consciousness might exhibit measurable correlations with quantum-based random number generators. Their findings, while controversial and debated within the scientific community, suggested that during moments of intense global focus, natural disasters, cultural celebrations, moments of collective grief or joy, these quantum devices showed subtle but statistically significant deviations from expected randomness. Now, this remains unproven, and many scientists argue that these correlations could reflect environmental factors, measurement errors, or statistical artifacts rather than consciousness effects. The scientific consensus has not validated these claims, and we must approach them with appropriate skepticism. But the possibility alone raises fascinating questions about the nature of collective human experience. Take a breath here and consider moments in your own life when you felt connected to something larger than yourself. Perhaps during a concert where thousands of people seem to move as one, or during a moment of shared silence after a tragedy, or while watching a sunrise with others. These experiences don't prove quantum connections between minds, but they do remind us that consciousness, even if individual, participates in collective patterns that we're only beginning to understand. Recent research in network neuroscience has revealed that individual brains exhibit remarkably similar patterns of activity during shared experiences. When people watch the same movie, listen to the same story, or engage in synchronized activities, their neural networks begin to synchronize in measurable ways. This synchronization operates through classical mechanisms: shared attention, mirror neurons, emotional contagion, but it demonstrates that consciousness is inherently relational, even at the level of brain activity. Some interpretations suggest, metaphorically speaking, that if consciousness involves quantum processes, then these moments of collective focus might create coherent patterns in the quantum fields underlying individual awareness. This is purely speculative, and no scientific consensus exists on whether such collective quantum effects are real. But the possibility invites us to consider consciousness not just as an individual phenomenon, but as something that might exhibit collective properties we don't fully understand. One of the most profound implications of quantum consciousness theory involves how it might reframe our understanding of attention and perception in everyday experience. The quantum measurement problem, the question of how indefinite quantum states become definite classical outcomes, might find its most intimate expression in the simple act of conscious observation. Every moment of your waking life involves countless acts of attention. You focus on these words, notice sounds around you, become aware of thoughts and sensations. Each of these moments of conscious attention involves what neuroscientists call selective attention, the process by which consciousness chooses what to focus on from the overwhelming stream of potential experiences available at any moment. Some interpretations of quantum consciousness suggest, metaphorically speaking, that these acts of attention might parallel quantum measurement processes. Just as quantum systems exist in superposition states until measured, your potential experiences might exist in a kind of superposition until attention collapses them into actual conscious moments. This doesn't mean that consciousness directly controls quantum events, or that attention literally collapses wave functions in the brain. Such claims would far exceed current scientific evidence. Rather, it suggests that the subjective experience of attention, the feeling of choosing what to focus on, the sense of possibilities becoming actualities, might reflect the same fundamental principles that govern quantum measurement processes throughout the universe. As you listen to these words right now, notice how your attention moves and shifts. You might become aware of background sounds, then return to the narrative, then notice a thought arising, then focus back on the content. This dance of attention feels voluntary yet spontaneous, directed yet flowing. Some researchers suggest this might reflect the quantum nature of consciousness itself, neither fully determined nor completely random, but operating in the subtle space between classical control and quantum indeterminacy. The implications extend to how we understand choice and decision-making in daily life. Traditional neuroscience suggests that decisions arise from the deterministic firing of neural networks. But if consciousness involves quantum processes, then the experience of choosing might reflect genuine quantum indeterminacy channeled through the complex information processing capabilities of the brain. As quantum technologies advance at an unprecedented pace, we're approaching a convergence point where human consciousness might interface directly with quantum computational systems. This isn't science fiction. Companies and research institutions are already developing prototypes of brain quantum computer interfaces designed to test fundamental questions about the nature of awareness itself. The implications are both thrilling and deeply concerning. If consciousness truly operates through quantum processes, then connecting human brains to quantum computers might expand the boundaries of individual awareness in ways we can barely imagine. Enhanced memory, expanded processing capacity, direct access to quantum information networks, even forms of technologically mediated, shared consciousness might become possible. But these possibilities raise profound questions about identity, autonomy, and what it means to be human. If consciousness can be technologically enhanced or modified, how do we preserve human dignity and equality? If awareness can be networked or shared through quantum interfaces, what happens to individual identity and privacy? These questions aren't merely theoretical. Research groups are actively developing technologies that could test whether human consciousness exhibits quantum properties. Brain imaging systems sensitive enough to detect quantum coherence in living tissue. Interfaces that could measure quantum entanglement between neural networks. Devices that might eventually allow conscious minds to interact directly with quantum information systems. As you contemplate these developments, take a moment to appreciate both the wonder and the responsibility they represent. The consciousness you're experiencing right now, this sense of being aware, of existing as a thinking, feeling being, might soon be understood and potentially enhanced in ways that transform the very nature of human experience. This convergence also raises questions about artificial consciousness. If awareness truly requires quantum processes operating in biological systems, then current approaches to artificial intelligence might be fundamentally limited. Silicon-based computers, no matter how sophisticated, operate according to classical principles that might never give rise to genuine consciousness. But quantum artificial intelligence systems might be different. Quantum computers operate according to the same principles that might underlie biological consciousness: superposition, entanglement, quantum measurement. Perhaps truly conscious artificial minds will require quantum substrates that can interface with the quantum foundations of awareness itself. As our understanding of consciousness and quantum mechanics deepens, entirely new approaches to healing and well-being are beginning to emerge. While we must be careful not to make unfounded therapeutic claims, the intersection of quantum physics and consciousness research is opening fascinating possibilities for understanding how practices like meditation, mindfulness, and contemplative awareness might influence the deepest levels of mental and physical health. Recent research has revealed that contemplative practices create measurable changes in brain structure and function. Long-term meditators show increased grey matter density in regions associated with attention and sensory processing. Mindfulness training enhances neural connectivity and reduces activity in brain networks associated with self-referential thinking and mental suffering. Some researchers suggest, cautiously and with appropriate scientific skepticism, that these practices might work by enhancing quantum coherence in neural tissue. Deep meditative states might represent moments when quantum processes in the brain achieve particularly high levels of organization and integration. This remains unproven, but it offers an intriguing framework for understanding how contemplative practices might influence consciousness at its most fundamental levels. The potential applications extend beyond individual well-being to collective healing. If consciousness does involve quantum processes that can become coherent across groups of individuals, then shared contemplative practices might create beneficial effects that extend beyond individual participants. Group meditation, collective prayer, synchronized breathing. These practices might work not just through psychological mechanisms, but through subtle quantum field effects that we're only beginning to understand. Take a breath and notice how considering these possibilities might affect your own relationship with contemplative practices. Whether through formal meditation, walking in nature, creative expression, or simple moments of mindful awareness, your exploration of consciousness might be touching quantum foundations that connect individual healing to larger patterns of coherence and well-being. It's important to emphasize that these ideas remain speculative, and no scientific consensus exists on whether contemplative practices directly influence quantum processes in the brain. The benefits of meditation and mindfulness are well documented through classical neuroscience, and we don't need quantum explanations to validate their therapeutic value. But the quantum perspective adds a dimension of mystery and possibility that enriches our understanding of how awareness itself might be cultivated and refined. And perhaps the most awe-inspiring implication of quantum consciousness theory involves placing human awareness within the vast cosmic context of universal evolution. If consciousness truly emerges from quantum processes, and if quantum mechanics operates according to universal principles throughout the cosmos, then awareness might be a far more fundamental feature of reality than we've traditionally assumed. This doesn't mean that rocks or planets are conscious in any human-like sense. Rather, it suggests that the capacity for consciousness, the ability for quantum processes to give rise to integrated, aware experience, might be woven into the fundamental structure of reality itself. Consciousness might emerge wherever conditions allow quantum processes to achieve sufficient complexity and integration. Recent discoveries in astrobiology have revealed that the chemical building blocks of life exist throughout the universe. Organic molecules have been detected in interstellar space, on comets and asteroids, even in the atmospheres of distant planets. If life is indeed widespread in the cosmos, and if consciousness is a natural consequence of quantum processes in complex biological systems, then awareness might be far more common than we've imagined. This cosmic perspective transforms our understanding of human consciousness from an isolated accident to a natural expression of the universe's capacity for self-awareness. The thoughts arising in your mind right now, the experience of being aware that you're reading these words, might be part of a vast cosmic process through which the universe explores its own nature through conscious beings. Some interpretations suggest, metaphorically speaking, that individual consciousness might be like waves on an ocean of cosmic awareness. Each conscious being represents a unique pattern of quantum coherence that temporarily emerges from and eventually returns to the larger field of potential consciousness that permeates reality itself. This remains purely speculative, far beyond current scientific evidence, but it offers a framework for understanding how individual consciousness might relate to universal principles. Rather than being separate from the cosmos, conscious beings might be expressions of the universe's inherent capacity for awareness, temporary focal points through which cosmic consciousness experiences itself. One of the most perplexing aspects of consciousness involves its relationship with time. Our subjective experience of time feels fundamentally different from the linear progression measured by clocks. Consciousness seems to exist in an eternal present moment that somehow contains memories of the past and anticipations of the future. Quantum consciousness theory offers intriguing possibilities for understanding these temporal mysteries. In quantum mechanics, time doesn't flow in the straightforward manner we experience in daily life. Quantum systems can exhibit what physicists call quantum superposition of temporal states, existing in multiple time configurations simultaneously. Some interpretations even suggest that quantum correlations can create connections between events separated in time, allowing the future to influence the past through quantum entanglement. If consciousness operates quantum mechanically, then our experience of time might be far more complex and interconnected than it appears. Memory might not simply be the storage and retrieval of past information, but could involve quantum processes that access information existing in superposition states across time. Each act of remembering might be a kind of quantum measurement that collapses temporal possibilities into specific recalled experiences. This could potentially explain some of the mysterious features of human temporal experience. Why do memories change each time we recall them? Why does time seem to slow down during intense experiences or speed up during periods of routine? Why do we sometimes have uncanny intuitions about future events or experience synchronicities that seem to transcend linear causality? As you reflect on your own experience of time, notice how the present moment you're inhabiting feels both instantaneous and eternal. Consciousness seems to exist in a moving point of now that somehow contains the richness of past experience and the openness of future possibility. Some interpretations suggest this might reflect the quantum nature of consciousness itself, existing in superposition states that transcend simple linear temporality. These ideas remain highly speculative, and no scientific consensus exists on whether consciousness truly exhibits quantum temporal properties. But they invite us to hold our assumptions about time and memory more lightly, while remaining open to possibilities that transcend classical understanding of temporal experience. Perhaps no aspect of quantum consciousness theory raises more profound questions than its implications for what happens to awareness at the moment of physical death. This ventures into territory that science typically avoids, but if consciousness truly involves quantum processes, then the relationship between awareness and mortality might be more complex than classical neuroscience suggests. Traditional materialist science proposes that consciousness is generated by neural activity, and when the brain dies, awareness simply ceases to exist. But quantum mechanics operates according to different principles than classical physics. Quantum information, unlike classical information, cannot be destroyed. It can only be transformed or redistributed according to the quantum conservation laws. Some interpretations suggest, cautiously and with appropriate scientific skepticism, that if consciousness involves quantum information processing, then the information patterns associated with individual awareness might persist in some form even after the death of the brain. This doesn't necessarily imply survival of personal identity or consciousness in any traditional sense, and it certainly doesn't validate religious beliefs about afterlife. Rather, it suggests that the quantum information patterns that give rise to consciousness might become part of the larger quantum field that underlies all reality. The unique patterns of quantum coherence that constitute individual awareness might be preserved in the universal quantum vacuum, even as the biological structures that supported them cease to function. This remains purely speculative, far beyond current scientific validation, and we must approach these ideas with extreme caution. No empirical evidence supports claims about consciousness surviving physical death, and such ideas should not be presented as scientific facts. But the quantum mechanical principles underlying consciousness do raise questions about information, identity, and continuity that classical approaches cannot address. Take a breath and consider how these possibilities might affect your own relationship with mortality. The quantum consciousness debate doesn't promise survival after death, but it does suggest that the relationship between consciousness and physical existence might be more mysterious and interconnected than materialist science typically acknowledges. As quantum consciousness research advances, we face unprecedented ethical questions about enhancing, modifying, or potentially transferring human awareness through technological means. If consciousness truly operates through quantum processes, then our developing quantum technologies might soon allow interventions into the fundamental nature of human awareness itself. The possibilities are both exciting and deeply troubling. Enhanced memory through quantum storage systems, expanded perception through quantum sensing networks, direct interface between human consciousness and quantum artificial intelligence systems. Even the potential for consciousness transfer or digital preservation of aware beings through quantum information processing. But these capabilities would raise profound questions about human identity, equality, and dignity. If consciousness can be technologically enhanced, how do we ensure that such technologies are available equitably, rather than creating new forms of cognitive inequality? If awareness can be modified or transferred, what happens to personal identity and the continuity of individual experience? The quantum consciousness debate also forces us to reconsider the moral status of various forms of conscious beings. If awareness can emerge from quantum processes in artificial systems, biological technological hybrids, or even collective quantum networks, then our ethical frameworks might need fundamental expansion to account for new forms of conscious existence. These questions become even more complex when we consider the possibility of collective or distributed consciousness. If quantum entanglement can create shared awareness between multiple minds, traditional concepts of individual rights and responsibilities might require complete reconceptualization. As you contemplate these ethical challenges, notice how they invite us to examine our deepest assumptions about personhood, identity, and moral consideration. The quantum foundations of consciousness might force humanity to develop new ethical frameworks that honor the dignity of awareness itself, regardless of the substrate in which it arises. Throughout human history, contemplatives and mystics have reported experiences that transcend the boundaries of ordinary consciousness, states of profound unity timeless awareness, direct perception of the fundamental nature of reality. These experiences have traditionally been understood through religious or spiritual frameworks, but quantum consciousness theory offers a potential scientific context for understanding them. If consciousness operates through quantum processes, then perhaps the extraordinary states reported by contemplatives represent moments when quantum coherence in the brain achieves particularly high levels of organization and integration. Deep meditative states might correspond to conditions where the quantum foundations of awareness become more accessible to direct experience. This doesn't validate any particular religious or philosophical interpretation of contemplative experience, but it does suggest that the systematic exploration of consciousness through contemplative practices might be investigating the same territory that quantum consciousness researchers are attempting to understand through scientific methods. The convergence of contemplative wisdom and quantum science creates possibilities for new forms of inquiry that honor both the rigor of scientific investigation and the depth of first-person contemplative insight. Future research might benefit from collaboration between scientists and experienced practitioners who have spent decades exploring the nature of consciousness from within. Some research groups are already conducting studies with advanced meditators using sophisticated brain imaging technologies to observe neural activity during deep contemplative states. These studies might eventually reveal whether contemplative practices enhance quantum coherence in brain tissue or create other measurable changes in the quantum processes underlying consciousness. Take a moment to consider how this convergence might apply to your own relationship with contemplative practice. Whether through meditation, contemplation, mindful awareness, or simply quiet reflection, your exploration of consciousness might be touching the same quantum foundations that scientists are investigating through technological means. At the farthest reaches of quantum consciousness theory lies perhaps its most radical implication, the possibility that the universe itself might be conscious in some fundamental sense. This isn't panpsychism in any naive form, but rather the suggestion that consciousness might be as fundamental to reality as space, time, matter, and energy. If consciousness emerges from quantum processes, and if quantum mechanics operates according to universal principles throughout the cosmos, then the capacity for awareness might be woven into the basic structure of physical reality. The universe might not be a mechanical system that accidentally produced conscious beings, but rather a conscious system expressing itself through the evolution of aware entities. This perspective suggests that human consciousness isn't separate from cosmic processes, but represents the universe becoming aware of itself through biological evolution. The thoughts arising in your mind, the experience of wonder you might feel contemplating these ideas, could be expressions of cosmic consciousness, exploring its own nature through conscious beings. Some interpretations propose that individual minds might be localized patterns in a universal field of consciousness, temporary focal points through which cosmic awareness experiences itself from particular perspectives. This would mean that while individual identity remains real and important, it exists within a larger context of universal consciousness that connects all aware beings. These ideas remain highly speculative, far beyond current scientific validation, and should be approached with appropriate skepticism. No empirical evidence supports claims about universal consciousness, and such concepts venture into metaphysical territory that science cannot definitively address. But they represent natural extensions of quantum consciousness theory applied to cosmic scales. As you reflect on these possibilities, notice how they might affect your sense of place and purpose in the universe. Whether or not the cosmos is conscious in any literal sense, the fact that conscious beings like yourself have emerged from cosmic evolution suggests a deep connection between awareness and the fundamental processes of reality. As we approach the conclusion of our exploration, it's worth reflecting on one of the most beautiful paradoxes of quantum consciousness research. The more we investigate consciousness scientifically, the more mysterious and wonderful it becomes. Rather than reducing awareness to mechanical processes, quantum consciousness theory reveals depths of mystery that inspire both rigorous investigation and profound wonder. This represents a fundamental shift in how science relates to consciousness. Traditional breaking it down into simpler components, neurons, neurotransmitters, electrical reductionist approaches sought to explain awareness by impulses. But quantum consciousness research suggests that consciousness might be irreducibly holistic, emerging from quantum processes that cannot be understood through classical reductionist methods. The holistic nature of quantum systems, where the whole is genuinely greater than the sum of its parts, might provide a scientific framework for understanding consciousness that preserves rather than diminishes its mystery and meaning. Quantum consciousness theory doesn't eliminate wonder, it deepens it by suggesting that awareness operates according to the most fundamental and mysterious principles in physics. This shift has profound implications for how we understand the relationship between scientific knowledge and human experience. Rather than science demystifying consciousness, quantum consciousness research reveals that awareness is intimately connected to the deepest mysteries of physical reality itself. The quantum realm operates according to principles that violate our everyday assumptions about reality. Superposition, entanglement, measurement effects, quantum creativity. If consciousness involves these processes, then awareness itself might be far stranger and more wonderful than classical science ever imagined. Take a breath and appreciate how this scientific mystery enhances rather than diminishes the wonder of your own conscious experience. The awareness you're experiencing right now, this capacity to think, feel, wonder, and contemplate the nature of existence itself, might be connected to the most profound mysteries in the universe. As quantum consciousness research continues to evolve, we stand at the threshold of discoveries that might fundamentally transform human understanding of mind, reality, and our place in the cosmos. The next decades will likely bring experimental evidence that either validates or refutes key predictions of quantum consciousness theory, potentially resolving one of the greatest scientific mysteries of our time. Advanced brain imaging technologies will soon allow researchers to observe quantum effects in living neural tissue with unprecedented precision. Quantum computers will provide platforms for testing whether consciousness can interface directly with quantum information systems. Collaborative research between scientists and contemplatives will explore whether awareness can be enhanced through practices that work with quantum processes. These developments will likely reveal whether consciousness truly operates through quantum mechanisms or whether classical neuroscience provides adequate explanations for awareness. But regardless of the outcome, the quantum consciousness debate has already accomplished something remarkable. It has expanded our sense of what's possible in the relationship between mind and reality. Whether quantum consciousness theory ultimately proves correct or remains forever in the realm of speculation, it has already transformed something fundamental about how we understand ourselves and our place in reality. It has reminded us that consciousness, your consciousness, might be far more mysterious, far more interconnected, and far more fundamental than we ever dared imagine. The terror this theory strikes in some scientists isn't really about the science itself. It's about what the theory represents, an invitation to hold our certainties more gently, to remain open to possibilities that stretch beyond the comfortable boundaries of classical materialism, to acknowledge that the universe might be stranger and more wonderful than our current paradigms suggest. As you go forward from this exploration, you might find yourself noticing your own awareness in new ways. The simple fact that you can think these thoughts, contemplate these mysteries, experience wonder about the nature of existence itself. This remains extraordinary, regardless of whether Consciousness emerges from quantum processes or classical neural networks. The quantum consciousness debate continues, as all great scientific mysteries should. But perhaps the most important insight isn't about finding final answers. Perhaps it's about preserving our capacity for wonder, our willingness to question, our appreciation for the profound mystery of being conscious in a universe that has evolved beings capable of contemplating their own existence. From Contemplative Science, where we explore the deepest mysteries at the intersection of mind and cosmos, thank you for joining this journey into one of the most controversial theories in modern science. The universe is vast, consciousness is mysterious, and wonder is always just a question away. Vast, consciousness is mysterious, and wonder is always just a question away.